Hello, everybody, and welcome to the Ruby Rogues. My name is John Epperson, and today on our panel we have Valentino Stoll.
Hey there.
And we have Ivo
Anjo.
Okay, Anjo. Yep, for guest today. And we're excited to have you, Ivo. Can you just tell us a little bit about yourself, what you've been doing, and maybe why people would recognize you out in the community?
Yes, so hello, I'm Ivo, and I'm originally from Portugal, and I'm a big fan of Linux, free and open source software, and Ruby, and also the Java virtual machine, so it's kind of weird. These are my two loves in terms of tech. So I really like working with Ruby and the whole community aspect and how people do really weird and interesting things with it. And my background being a bit from half Ruby, half Java, I think I bring an interesting point of view in terms of wishing that I could do some things with Ruby that I also can do with Java, and also bringing a bit of the context there. So why should people check out what I do is because I do weird things with Ruby, and I'm interested in pushing Ruby really hard and doing even weirder things with Ruby and getting more out of Ruby, because I think that Ruby still has a lot of mileage to go, a lot of interesting things that people will still do with Ruby, and I think all of the rumors in terms of Ruby's death have been wildly exaggerated.
Here. We don't have Luke to jump in there, but yeah, awesome.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So we ran across your blog post talking about unsafe concurrent Ruby patterns, which is why we originally wanted to yap with you or whatever. And we actually talked about Ractors a while back, and hopefully we got most of the things right, because I think that we were trying to figure them out at the time. But can you maybe just get us straight on some of that stuff? So can you talk about what a Ractor is, maybe just from a high level, so that we have that context as we're yapping about stuff?
Yeah. So a Ractor in Ruby is something that is similar-ish, but not exactly the same as an actor that the people might have heard of from other languages, such as Erlang, Elixir, or even Scala. So the idea is that actors are new entities that came in Ruby 3, and these entities can only communicate via message passing, instead of normal Ruby objects communicate, which is via sending messages to each other and by calling methods and passing arguments around and whatnot. So unlike Ruby methods, Ractors communicate just by this mechanism of exchanging messages, and in particular, messages need to be immutable things, and so that multiple Ractors cannot be at the same time accessing mutable states.
So a couple clarification questions. So my understanding, so first of all, it always made sense to me that Ractor was Ruby actor, right? That's what it meant. But yeah, since in Ruby, calling a method on another object is quote unquote sending a message. For clarification, I think what we're talking about here is more similar to if you're using a Kafka queue or something like that type of message, right? It's a message queue that's completely separate from sending messages via hitting send.
Yes, actually, it's that end. So there's actually two ways in which Ractors can communicate. One of them is via this message queue, which, as you said, is is much closer to a Kafka queue than calling a method. And on this, when we communicate via this way, communication is asynchronous. So you put something on the queue, and then sometime later the Ractor might read it. And there's actually another way for Ractors to communicate, where a Ractor can basically block until another Ractor comes in and says, I'm here to take some information from you, and the the other actor will be blocking, saying, I'm here waiting for someone to come in and take some information from me. So there's actually this different option where the queue is like a Ractor ends up waiting on a queue of size 1 and will block until there's something. It can either read or get something from that queue.
So you can have like a dependent message?
Yes, in a way. So effectively, the Ractor can say, I'm waiting for someone to hand me over some information before I can continue. Or another Ractor can say, like, I'm waiting until I can hand over some information to another Ractor, which is different from the asynchronous approach.
Yeah, that makes sense. Like you're just blocking until your asynchronous request gets handled, sort of. My video cut out. I don't know if that's a problem.
So, Ivo, what advantages are you seeing to the new Ractor implementation?
I think right now, still not a lot because we're still in the very early times. So right now, Ractors are something for early experimenters and people to explore and figure out how to use and what are the correct patterns and things that we should do and shouldn't do. But I really like Ractors because I think they're an interesting extension of how people already did concurrency in Ruby. So it was very common for people that wanted to take advantage of multiple cores on their machine to use several Ruby processes. And these Ruby processes could communicate via a socket or something that gets shared, and they would not be able to directly share memory. So I think the Ractor model ends up being, what if we took this model that web servers and other Ruby tools do, where they just communicate via across different processes, and we put all of them inside the same Ruby process, and inside that process they can communicate via this Ractor abstraction.
Sweet. I love Riverside. I mean, there's some definitely good parts about it, but so now that we've talked a little bit about Ractors, so let's talk about some of the unsafe concurrent Ruby patterns that you ran into. I'm like super interested in this. I haven't had a lot of application myself to do a lot of concurrency, right? Like, for the most part, like I write web apps, and web apps right now, you don't need concurrency. So in certain use cases, maybe you would need it. But I feel like I'm in the place of a lot of Ruby users where it's like, oh, this is really cool and I would like to use it someday, but I literally haven't had a meeting that I've come out of with a requirement that I was like, this justifies concurrency. So I'm not there yet. What am I going to run into when I start doing it?
Yeah, so definitely the interesting challenge about Ruby is that in some ways, and here's where my Java background kicks in, is that in some ways, even though in Ruby you cannot have multiple threads running in parallel, so you cannot have multiple threads that are working on the same at the same time on Ruby code, you have concurrency, which is like multiple threads are working, but only one of them runs at a time. But even though Ruby has this simplified model, it still ends up having a lot of the same pitfalls that you get when you have parallelism, which is that you don't know when the multiple Ruby threads that you might be executing, you have no control over that. And so that means that if you are trying to share data among multiple threads and you are trying to read something from a thread at the same time as another tries to write, you have basically no guarantees that things are going to go how you would expect it to go if you are looking at it as if it was just a single thread. So you need to always be thinking, what happens if between this line and this line, another thread comes in? And so the challenge with Ruby, I would say, is that at least in the base language, there's not a lot of classes and like helper tools to help you out and do correct things here. And so over time, a lot of Ruby developers have adopted like some strategies, but in my experience sometimes is that some of those strategies might not be as correct or foolproof as you would expect by looking at them. And so my experience with this actually started with like the second Ruby app I've worked with was a very complex application that coordinated a lot of calls using a lot of phone calls using the Twilio APIs. So if you're not familiar with Twilio, it provides you an API to control and make phone calls and then join callers together and do a lot of interesting things. And so you would have this problem of like in a phone call, there are multiple people and people would come in, they would come out, they would press buttons, they would try to do some things. And so this application had to deal with this kind of concurrency. There were multiple things happening at the same time in a phone call. And so this was my kind of trial by fire, where I had to learn a lot of these things the hard way by either writing them and running into issues, or debugging them if someone had written them there. So definitely in this presentation I made, and like the blog post that I made afterwards, I try to kind of distill some of the interesting things that I found out about things you should and should not do in Ruby, and things you should be on the lookout. Whoops, if you do this, it might seem correct, but it's actually not, and you might run into issues when you have concurrency.
It's true. So the last time I dealt with concurrency, I don't know if you have any thoughts, Valentino. The last time I dealt with it wasn't actually even in Ruby. It was, so my first gig was for an auction company, and we did livestock auctions. And so we would broadcast the video and audio real time, and that was actually a Flex application. So if you're familiar with ActionScript from back in the day, Flash stuff, that's what we used, and there was some amount of concurrency there. Though, to be fair, much like Ruby, most of ActionScript is limited to a single thread, so you would have to, but there was some quirkiness to it, just like Ruby. But yeah.
That was Java based too, wasn't it? Flex.
It could be. So we actually had a Ruby backend or Rails backend, and those were literally my first commits on GitHub, were to like an extension to like the API that we were using or whatever.
Yeah, definitely the part of the challenge is that with this kind of concurrency, when you're looking at the concurrency bug, it often is non-deterministic. And so what that means is it might happen, it might not happen, and you never know if it will happen or not. And they usually happen when the application is busier, more loaded, has more events, slower, etc. And so it's one of those things where you write the code, you test it on staging, it looks fine, you test it on your other environments, pre-prod, etc. It's fine, and then you throw it in production, and then like once in a while, maybe every 1 minute, maybe every 5 minutes, maybe every day, maybe every week, something really weird and something really broken happens that can even take your application down, and you are completely baffled because you cannot at all see it happen like on your machine, on any other testing environments, because they don't have enough traffic coming in and out and enough things happening at the same time to be able to actually trigger the issue. And this is why these issues are both interesting as well as really hard to debug and to catch.
Yeah, my concurrency experience is mostly Kafka related or message queue bound, right? Where there's a separate system that you're offloading that concurrency to. The Ruby stuff is really interesting. I have a lot of problems with it. It's like you said, it's still immature, but also like because of that, it's hard to get started with. So my experience is I'm not very much in that concurrency realm yet, and a lot of my hesitation is because Ruby is immature to dive into it with Ruby, right? And I imagine that's the same case with a lot of people, where a lot of this stuff is new and not really ironed out yet. But my one experience was with hardware, where I had a Raspberry Pi hooked up to a bunch of GPIOs that I wanted to be concurrent and have a block of Ruby execute for each GPIO, and ran into a ton of issues joining the threads for that.
Definitely, like usually the safest thing in Ruby is to try to avoid concurrency if you can. And that has kind of been the thing so far. And the interesting thing about Ractors, bringing this a bit full circle, is that if Ractors kind of pan out and more libraries and tools in the Ruby community build on top of it, I hope that it's going to be the thing that demystifies and makes the concurrency both easy as well as safe in Ruby. Because right now you can definitely do it, but it's challenging and you need to be rather careful with what you're doing and and how you're using it. And the promise of Ractors is, okay, you will have multiple Ractors, and as long as you follow these very simple rules, you communicate via sending messages and a few other things, then hopefully this will be fine, and you will it will be easy to debug your application, and you will not have like mysterious failures. So this is what I'm really hoping that the Ractors bring into the Ruby community, although they aren't there right now. And that's kind of, while I was exploring Ractors, it's what led me to write my blog post, where I ran into this issue where While if a Ractor runs too slow, then the whole Ruby app can crash because there's no way for another Ractor to, there's no built-in way for another Ractor to say, hold up, too much work. And so work can just pile up if a Ractor is not actively looking at its input message queue.
There's some really good points here, right? So Valentino, I think you made a good point. I'm just kind of tying these together. You brought a good really point up. We're already using, I keep forgetting that, using Sidekick, using Kafka, all of those things, those are concurrency, right? Not of the same type, but they are. You have some of those problems,
and even
you have to deal with them.
And even like on modern Rails apps, I believe right now the default web server when you create a Rails app is Puma. And Puma actually has multiple configurations, and I'm not sure what the defaults are actually. I haven't checked in a while, but one of the configurations that Puma allows you is to have multiple threads. So even though your code might not explicitly create multiple threads and do things, well, maybe your web server has created them for you and is using them. So that's one of the things where it's rather important to be aware of the Puma configuration and how it's set up, because it can be using multiple processes that are separated, or it can use threads, or it can use a mix of both. And if you are using threads, then it's possible to run into some of the issues with concurrency.
Yep. I mean, this is okay. So getting to a specific thread problem, right? This is the reason why we say, be careful when you're using global variables. Or you'll often hear people say, never use global variables. But what they really mean is like, use them sparingly, know what you're doing. That's like, global variables are a great way for thread problems to be introduced, right? Like it's one thing to put it in an initializer, right? So probably the most common use of global variables I can think of off the top of my head is in your Sidekick initializer, your Redis initializer or something, right? You probably have a global variable for Redis. Like that's a really common pattern that I see all over the place. When you run it in your initializers, that gets set up before like threads get made. So all of your threads all have that global variable set on them. But if you set a global variable later on during your app life, that's not guaranteed to be on every single thread. So you can run into issues there.
It's not actually like it. If you set something after creating threads, it will be visible by the multiple threads. The problem is they might not see it at the same time. So especially if you have multiple threads at the same time, when you write something that is lazy, for instance, where you check, does this exist? If not, create a Redis configuration. That's when it's really problematic, because otherwise, you can still create like global variables and write to them even after creating threads. The problem becomes when you have multiple threads trying to read or write that thing at the same time. It's when it becomes harder to predict what's going to happen, and then you need to reach out for some concurrency tools such as monitors and such helper classes, so that you can kind of control what's up and avoid any issues.
Okay, so I might have gotten something slightly wrong there. So to clarify then, so the issue, my understanding was that if I have two threads, for example, right? So thread 1 and 2, and I assign global variable A on thread 1, thread 2 does not have that value in that variable.
Thread 2 will be able to see that value.
Okay, so the issue is only when I'm writing. Okay, then. All right.
The problem becomes like, when does it see it? So for instance, if you start two threads at the same time, and the first thread you start, the first thing it does is write to this global variable. And then the second thread you start, the first thing it does is read from this global variable. It's possible that because threads execute concurrently, you actually in your code, you created like thread number 1 and thread number 1 assigned to this global variable, and then thread number 2 read from this global variable. But there's no guarantee in Ruby that Ruby will actually follow this order. And so it's possible that Ruby actually will start the second thread first and then try to read from the global variable without the first thread actually having gotten the opportunity to write to it. So this is kind of the issue, is that if you coordinate between threads, and there are some ways to coordinate between threads, you can be assured that everyone will kind of see each other. But if you have no way of coordinating, then you never know who's ahead of and who's falling behind and who has written what effectively.
So, and this actually is a unintentional example of what I was actually trying to get to earlier, which is like, and that you kind of brought up, which is like the tooling. I'm sorry. there's a lot of stuff to think about when you're thinking about threads. And if you don't deal with threads for like many years, then you like get back into it and you have to kind of relearn every time because there's like legit a lot of stuff to think about. I don't remember all the lock types, for example, things like that. I don't remember the use cases of which kind I want to use where. But like the thing about threading today is that there's a lot of context that you have to hold in your head that isn't your code. It's just how do I thread when you're doing threading coding. And yeah, I think my hope for Ractors is that gets better.
Yeah, I think that's why they were added. Like it's the Matt has talked about in a bunch of his presentations about how he was never quite happy with what we got out of Ruby threads, and that they are not like programmer happiness, like developer happiness as a lot of other Ruby things aim to be. And definitely it's hard to like remember all of these special cases and to get them right. And the problem is that sometimes you get them almost right and things almost work, and then they break sometime later, which is the really annoying part, is the almost. It's much better if things fail immediately because oh, I got it wrong. But when they fail sometime, maybe in the customers, in like when a customer is doing something, not when you're doing something, that's when it becomes really hard.
Race conditions.
Yes, exactly.
All right. So, now that I brought that one up, any other like hangups with threads that you like maybe want to highlight that are like either like easy to fall into, hard to see, or anything like that?
Yeah, actually, the thing I was using as an example earlier is a thing that has tripped me, and I've tripped over on it. Is like in Ruby, it's really common to use the pattern of creating things lazily, where you would usually go something pipe equals some initialization value, and it's like you see that this pattern all the time in Ruby code, which is like, okay, we may not want to compute something eagerly, but the first time something is accessed, you want it to be created and then stored, and from them on reused. So this is a really common pattern in Ruby, at least in my experience, and this is one of those patterns that is completely trips you under several threads, because what can happen is that if you have multiple threads that are at the same time trying to get this value, and they all will at the same time run into the same initialization. So you can have like two threads, they both go into a method, they try to read some value, they find that the value is nil, and then they both at the same time both decide, let's initialize this new value, and then they do the initialization, and then they assign to the value, and then they go out. And this is a race condition, and so one of them will win and the other will lose. But the problem is, well, if you're just initializing some hash, some string, something that it's harmless, then no, there's no problem. You did a bit of extra work, but this has no big impact. But for instance, I've had issues in production where a database driver was being initialized like this, and so actually multiple threads would cause multiple database drivers to be created. And the problem was that actually the database driver used its own background threads. So actually at some point in that application, we would run out of threads because we had so many leftover database driver connections that had been created accidentally by the application. And like this pattern of or equals in Ruby is like really nice, and I use it every time I can, but every time I'm about to use it, I pause and think, do I expect this to be used across multiple threads? And no, fine. Yes, then let's do something else, because otherwise I'm just introducing a new bug here.
I find that super interesting. I mean, I remember I've had to do mutex locking on around some database calls before, but yeah, the lazy loading thing, I literally use it everywhere. I will say I definitely use it for like, how should I put this? So I'm pretty big into like using OOP for like modeling, right? And using functional style for like processing, right? So, and when you're modeling, your lazy loads are really just more like virtual attributes than anything. So I always feel pretty safe about that kind of stuff. Like the worst thing that typically would happen is maybe you might recalculate something that you calculated before, right? But yeah, I think I get uncomfortable with lazy loading in something that I consider to be functional, like in a processor of some kind, right? So maybe I mean I don't really intentionally do concurrency anyway, so I'm probably not going to run into this issue as it is, but it may just be like a
Maybe you have one of these in your application just writing to Spring. Hopefully not.
Very possible, actually.
But yeah, like the thing is, it's for most applications you always have bugs. So it's annoying to have these. These are the worst kind of bugs, but they're bugs on top of other bugs that you might have. So they are, yeah, you always have bugs and you always try to fix them. It's not different from that point of view. Like no application is perfect except maybe the empty one.
In your article, you offered mutexes as a reasonable solution for this. That works pretty good in your experience then?
Yes. Mutexes were built to basically provide coordination between threads, so that if multiple threads are trying to do something at the same time, you get what it's usually called mutual exclusion. So it just means they go in one at a time, they do what they need to do, and then the next one can come in. And so mutexes create this point where basically they eliminate concurrency for some block of code that you pass in when you are using the mutex. So you basically say, execute this block of code, and this block of code can only be executed by one thread at a time. If there are multiple, then the others just wait until it's their turn. And by introducing this concept of like everyone goes their own turn, then you eliminate concurrency, and by eliminating concurrency, well, you don't have problems anymore. So a mutex is a tool to eliminate concurrency strategically in parts where you know, well, if there's concurrency here, there's going to be problems.
Got it. But that also, then you have to think about, okay, I'm creating a line right here. It can be a performance bottleneck or whatever. So you don't want, obviously this is coming from somebody who learned about mutexes in school and hasn't used them professionally outside of a few special cases, but you don't want to have like a very long, large method that's calculating a bunch of stuff be wrapped in a mutex. You want small pieces of it to be locked in, because otherwise you're literally putting everyone in behind a line.
Exactly. So you need to be careful, because like if you don't, then you can effectively do what Ruby does itself, because that's what Ruby does internally. So internally, Ruby has its own mutex, and only one Ruby thread can be running at a time. And like if you are not careful and you put like a mutex around like a too big block or a too big slice of your application, then you get effectively this. Only one will go in at the time and be able to do anything.
Awesome.
So Ivo, we've talked a lot about kind of some drawbacks of concurrency and kind of some pitfalls that you've outlined that are pretty great. What pieces of Ractor have you seen that you really like and are kind of excited about to expand on?
One of the pieces I like the most, which is maybe not the more obvious one, is how for Ractors to work, you actually they can only send immutable things between them. So things that cannot be changed. And so like things that cannot be changed is a concept that exists in Ruby, but it's quite common for you to change stuff all the time in Ruby and in object-oriented programming in general. That's quite common. And so because if you can only use Ractors if you start creating these kind of immutable objects that you create and then you don't change anymore, which I think that will bring a very positive approach to the ecosystem, because more people will start to use immutable objects and go a bit closer to functional programming using objects than using like a lot of mutable stuff and writing and changing objects all the time. And so the part of Ractors that really excites me is that for them to really work and be successful, then we need to have more tools and more easier ways to have immutable stuff in Ruby and pass immutable stuff around. And I think I kind of try to follow the Ruby core mailing list, and we seem to be that there are ongoing conversations around adding more tools and easier ways of creating different kinds of Ruby objects that are immutable. And so I think this, even if people end up not using Ractors and they use regular threads, or even if they don't use any of that and they continue using their own code, I think by making it easier to create things that are immutable and by kind of forcing libraries to use more and more of these things, there will be a lot of gain to the Ruby ecosystem, even if you never end up using Ractors directly.
Yeah, I like that a lot too. I think Samuel Williams is working on that immutable module to get integrated into the Ruby ecosystem. I definitely like that. It's kind of nice if you work with Sidekick or any of these workers, right, where they need to be immutable, otherwise they could get run again, right? Because it just pulls off the queue and works on it. So I think we're already getting there as Rubyists, right? To keep in mind of, okay, you want to do this task, make sure it's immutable and wrapped in its own ecosystem. And I think that's a good place to kind of drive toward that concurrency models.
Completely. If you have multiple threads, but you are only sharing immutable things and you are not like reading from one thread and writing from another, then that simplifies things a lot as well. So the issue is always when there are multiple threads changing things at the same time. If that doesn't happen, then like everything else becomes a lot more simpler, which is kind of the selling point for a lot of other languages that go further than Ruby and they just say, oh, you cannot mutate stuff at all. Done.
It's nice to be able to have your cake and eat it too. I'm not gonna lie.
Yeah, and I think like Ruby's approach of letting you pick and choose, like in this case, like it's okay. I can use this immutable approach. In other case, I prefer using another different style of expressing my code. I think that's really where Ruby's power come in, of making it easier to use several styles as needed to solve like different problems. And I think Ruby is really adaptable because of that property as well.
Yep, I'm a huge fan of that. So we're all very excited for the new Ractor-based server then, which I can't remember off the top of my head. Falcon, that's what it was.
Yeah, I think Falcon right now, is it? I'm not sure if it's using Ractors yet, but I think at some point there it makes sense for it to do that.
Yeah, hang on. All right, now I gotta look this up.
I thought it was still in that async ecosystem.
And that whole ecosystem, I think, will also benefit from all of this work because...
Oh, you're right. I thought that we were... Okay, that's fair. I could have sworn I had Ractors in my head when I was thinking about Falcon, but you're correct. It's using async.
I think the confusion might have come from because Samuel Williams has been doing a lot of contributions to Ruby. And in Ruby 3, there was a lot of work around the async work and scheduler, IO schedulers and whatnot at the same time as Ractors made it in. So it might have seen that the two things were the same, but they're actually like related concepts and like different people working on having different concurrency things on the JVM. On Ruby.
That was a follow-up topic I'd like to explore, if you're willing, Ivo, is because you have a lot of JRuby or Java. Do you have JRuby background, or is it just Java?
I've used JRuby and I've used like regular Java, boring Java.
So I guess where are some parallels that you see Ractors in relationship to the JRuby ecosystem, as far as like what advantages do you see Ractors taking over the JRuby ecosystem, or vice versa? So
JRuby is really interesting because it has a lot of nice properties that if well tuned, it's definitely faster than regular Ruby. And you can get like multiple threads really running at the same time, so you get like real parallelism. But it also means that if there is a concurrency issue in your code, maybe it most of the time works in regular Ruby. But once you go to JRuby, then like JRuby will a lot more often trigger the issue because, well, JRuby has that many more opportunities for things to go wrong because threads are working and running Ruby code at the same time. So I do think that Ractors also make sense to apply to JRuby as well, although you get less of a gain on JRuby. So part of the selling point of Ractors is that they break one of the most fundamental assumptions in the Ruby virtual machine, which is that only one thread can be running Ruby code at a time. This happens because Ruby, or the C Ruby implementation, has something that they call the global VM lock. And so threads take and release this global VM lock before they are able to run Ruby code. And Ractors, one of the big selling points is that instead of being, in Ruby 3, instead of being one global VM lock, there's no longer a global VM lock, there's actually a VM lock per Ractor. So if you have 3 Ractors, or let's say 4 to have a nicer number, if you have 4 Ractors and you have a 4-core computer, like you can have 4 Ractors at the same time crunching through Ruby code, and they will be executing, and they will be using all of your 4 or 8 or 16 if you increase the number of Ractor cores on your machine. So that's that has been a big selling point for other languages, and Ruby can get there now using Ractors. And in JRuby, you actually don't need to use Ractors to get this property of I get more threads and all of them are running at the same time. So Ractors for JRuby, they bring more the safety and easy to program aspect of concurrency and less the performance potential. So I don't think you will get more in terms of performance out of JRuby once it has Ractors. You will, but it will be safer if you rewrite your code using Ractors, and JRuby provides Ractors. So I think that's how I would put the comparison between both of them.
That's really interesting. I didn't know that the Ractor implementation was wrapped around GVL like that. Is it GVL?
Yes.
I always forget.
Usually people say
GVL.
JVL. It's the global VM lock.
Yeah.
Oh, I thought we always called it the GIL, but okay.
Actually, it's one of those things that the GIL is what Python people call their JVL, and so that name has kind of stuck. But I believe like all of the Ruby core developers, every time they're talking about it, they call it the JVL. But usually when myself, a lot of the time when I'm talking to other developers and like about like VM stuff, usually I just say the GIL, because if someone is not from the Ruby ecosystem and has not looked at some of the talks from Matt and the other Ruby developers, it's much more common that they know exactly what you mean when you say Ruby has a GIL versus Ruby has the JVL.
That makes sense. No worries. Yeah, I certainly didn't want to be pedantic there. I was just definitely curious.
No, it's like I think it's a very common thing. So I use them interchangeably, and I don't think it makes a big difference.
Yeah, sweet.
Time is of the essence when identifying and resolving issues in your software, and our friends at Raygun are here to help. Their brand new alerting feature is now available for crash reporting and real user monitoring to make sure you're quickly notified of the errors, crashes, and front-end performance issues that matter most to you and your business. Set thresholds for your alert based on an increase in error count, a spike in load time, or new issues introduced in the latest deployment, along with custom filters that give you even greater control. Assign multiple users to ensure the right team members are notified, with alerts linked directly to the issue in Raygun, taking you to the root cause faster. Never miss another mission-critical issue in your software again. Try Raygun Alerting today and create a world-class issue resolution workflow that gives you and your customer peace of mind. Visit raygun.com to learn more. Their simple usage plans start from as little as $4 per month with unlimited apps and users. That's raygun.com to start your free 14-day trial.
Yeah, I think for me, the most exciting part about Ractor is I feel like no one's promising this, but like for me, I'm looking at it like I have a GIL for each Ractor, right? Which means that I can feel like my code is not going to be running concurrently with anything. It's not, because all the Ractors are running next to each other, so they're never mind. There's no safety guaranteed by that at all.
There is some, because Ractors cannot directly interfere with each other. So that's the big advantage, is that Ractors restrict what you can do, and so by restricting what you can do, they kind of help you not do the wrong thing, because it's not impossible, but it's really, really, really hard to do the wrong thing using Ractors and to shoot yourself in the foot, for instance, in the ways I was describing on my Unsafe Concurrent Ruby Patterns blog post, because a bunch of the things I was showing there, you effectively cannot do when you have Ractors. And so by preventing you from doing those things, it takes away like a big foot gun that you would accidentally shoot your foot off with.
Oh, so let's talk about that real quick. Aren't Ractors sharing memory space?
Yes and no. So Ractors, they are all inside the same Ruby process and the same Ruby VM. They share the same classes, the same modules, etc. But they cannot share instances of objects. Like you cannot share objects between them unless the objects are immutable. And so if they are immutable, it's okay to share these objects or even to copy them, because, well, you cannot run into issues with immutable objects because they cannot change. And so the fact that they all run inside the same address space is really not, it's more of an implementation detail. So if you look at like how Ruby runs under the hood, that's how it does it. But if you could implement Ractors by, for instance, creating multiple Ruby processes and just having them exchange messages, and so you could even use this strategy to bring like the Ractor implementation to earlier versions of Ruby if you were really bored like one weekend. And because the way that Ractors work, like you would get the same, almost the same kind of properties between them. So that's, you end up having this nice property of you all run in the same process. So you don't have multiple copies of classes, you don't have multiple copies of your code. You can kind of share the garbage collector and all of those things, but you get a lot of isolation that Ruby enforces. And so it helps you not run into issues because of that.
Okay, I think I got some confusion because we were talking about your blog post, which is talking about general concurrency, and I was thinking that was applying to Ractors. Okay, so then if I'm just sharing like, okay, yeah. So if I'm just sharing only immutable objects, and for example, all my local variables and other things that are, well, I mean, there's a lot of immutable objects in Ruby, but like all my things that are mutable are more or less duplicates of each other, then I'm getting thread safety at the cost of more RAM, basically.
Yes. So if you have to create copies of things, then yes, you would have more memory usage. But if you do freeze things and you have like one copy of things that is immutable, then you can share things and you don't have that memory impact. So you basically you have both options. You can either copy stuff, and so by copying it to guarantee that there's no conflicts, but you pay using more memory, or you can make it immutable, and in that way you can share it directly, but well, you cannot mutate. So you will need to change your classes, your code, and any libraries that you use to be able to take advantage of this pattern.
Yeah. So I mean, I use functional style all over the place, not with everything, but with a lot of things. So that makes complete sense to have immutable stuff. I don't mark everything as immutable, but I make the assumption, right? So there's obviously some work to do for people like me who aren't using libraries that force things to be immutable, but it's doable. And with Ruby having like first class functional support, that's totally a thing you could do. Okay, awesome. I would totally buy that even with the memory increase, to be honest, because memory's not free, but memory's pretty cheap, right? Especially for us Rubyists who have already like gone down the road of being like, oh, just add more RAM to it, it's fine.
Yeah, usually Ruby applications, like you can usually not, like you run into memory constraints if you are trying to have like multiple like processes or threads like in a Puma web server or something like that. But if you don't have concurrency, you usually don't run into too many memory issues in Ruby. So
yes,
usually not a big problem.
Awesome. Yep. Usually happens when you have lots of requests coming in that all want PDFs or something. That's the thing that always gets me. That's the one that I always think of. Awesome. Okay. Yeah. That is. Geez, is this what you were going for, Valentino? Because this is. I'd forgotten about that part, obviously, and got myself confused.
What's that?
The fact that Ractors are more or less giving you the thread safety, so you don't have to do it. Yep.
Yeah, exactly.
Okay.
Yeah, I mean, I'm kind of curious how, because I think the way that the async framework works is they have kind of like a reactor on top, which ultimately Ractors within Ruby would act similar ways if they each had their own GVL, right? Where it would be almost like a reactor on top of that particular Ractor.
It's
wrapper.
Somewhat different. So but they can kind of work together. So the thing about the reactor is that it usually encapsulates a pattern where your code runs for a bit, and then once your code is about to block for some reason, because, well, it's reading from the database, it's calling a different service, it's going to like read a file, anything that would cause your code to block, your code, instead of blocking, it yields to the reactor and says like, okay, like please put me in the queue and wake me up when there's something for me to do. And so async works a bit like works like that. So you can have multiple of these fibers. It usually uses fibers, so you can have multiple things going on, and once they block, they get put on a queue and they get woken up when there's any something for them to do. It's somewhat different from Ractors, because Ractors, inside the Ractor, you can actually block, and if you block, then the Ractor will be blocked until there's something for it to do, and the same Ractor will not then stop doing what it was doing and then pick up some other bit of work, which is what you get from a reactor. But if you start using both of them together, it means that you can have like a reactor per Ractor or something, some combination like this, where you can have you can have the property of having multiple Ractors working in different cores on your server, and they will all be working at the same time, and all of them have a reactor, and all of them apply this pattern of they do some work, and when they are about to block, they just park that work and go do something else. And so this would probably be one of the configurations that allows you to have like the most performance out of your server using Ruby in the future.
I see. Yeah, that makes a lot more sense. So how does the new, I don't know if you're familiar with this or not, but how does the new fiber scheduler work with Ractor? Are they completely separate things, or is it integrated?
Well, as far as I know, they are completely separate. And
Okay.
the trick about the fiber scheduler is that, well, I know a bit about it. So please take what I'm saying with a medium-sized grain of salt, because I might be wrong. So sorry, Samuel Williams, if I got this wrong. But my understanding is that there have been other attempts of doing something like the async ecosystem is doing for Ruby. Like in the past, there was the very well-known event machine, and there have been other gems that have tried to do this. Usually the problem they run into is that a lot of the, HTTP clients, database drivers, etc., that people tend to use with Ruby, they are not ready to use a reactor. They are not like reactor friendly. And so you always have this problem of you would need like reactor ready, or event machine ready libraries that would do the right thing when you are about to block. And that is really annoying, because it's it's kind of an uphill battle, because you need to modify everything that your application does. And what if one of the libraries you're using or you wanted to use doesn't do that? Like it kind of leaves you stuck. You either have to do a lot of work to maybe, like if it's an open source library, you fork it, etc. So, but you don't want to do that. And the key thing about the scheduler that was added on recently to Ruby is to have this property of automatically allowing existing code to be reactor friendly. So what if you could take your HTTP client gem that has been working fine for a long time, and when it is about to block, then it automatically makes use of the scheduler. And this is what Ruby added recently. And so it means that it kind of removed this big blocker of you needing to think, are all of my libraries friendly to using reactors, or do I need to change or modify them? And instead you can just say, okay, they should be fine. Of course, there's I think there's a few things to know about it, but I believe that the intent is that in general things will just work. And so you no longer need to change your dependencies or to go around patching stuff in the ecosystem. So that's pretty powerful. And again, going back to a bit the Java reference, Java is actually trying to do the same thing right now. And so it's kind of interesting to see that Ruby got there first, and people are actually looking to add the same thing to Java that has exactly the same problem, which is when you want to use this pattern of reactor-like pattern, then you also don't want to change all of your libraries in the Java ecosystem either. So it's much nicer if you have something that does it for you automatically.
Yeah, I know for me personally, the reactor pattern makes a lot more sense. But I don't work in concurrency all the time, so.
and it has been proven very successful with Node, right? Node really was the big thing, the big tool that brought this kind of programming to the masses, at least that I know of. And it really, I think it has more than proved that this model can work quite nicely, and you can do quite nice things with it. Yeah.
I mean, we did have it
For sure.
well before that, but I think that you're right that Node kind of
Yeah, definitely Node was not the first, but I think like
tooling.
was the first that really like was really, really widely used.
Yeah, awesome. Yeah, I don't know. I guess this conversation has been interesting because you brought that question of Valentino, and I was like, well, I've always separated asynchronous, work from being threading, but I guess like it is technically like a paralleling technique. So yeah, I mean, I definitely had. I was thinking about. I was like sitting here like, okay, what do I think about this? Because that's a good point. And like now I'm like trying to fudge it all together, right? Because I always looked at it as like asynchronous is what I do when I need to run things asynchronously, right? Like and not synchronously, and I need more than one worker or something, but I don't want threading. But yeah, it is solving the same problem. So okay. This has been a very interesting conversation for me. I think so. While we've been talking, not only did I have to replace like a couple assumptions that I walked into this conversation with that were wrong, but I also was like, well, crap. And I've been like sitting here like doing some reading too to try and like refresh because we haven't talked about Ractors and fibers in well over 6 months, and I haven't used them. And
So
go ahead.
let's ask Ivo here.
Yeah.
Ivo, what are you using them for?
Well, in the past, I've used a lot of in this that Ruby app where I worked that had a lot of concurrency. We had a lot of these things, not Ractors at the time. There weren't any Ractors, and then I also worked on like a JRuby application that was really focused on like the performance of what it was doing and used a lot of threads. And so I'm kind of not using Ractors yet because I believe that it's very, very early to use Ractors in Ruby 3.0. So I think right now Ractors in Ruby 3.0 is more about exploring and learning and kind of feeding that information to the Ruby ecosystem and to the Ruby core developers, and something that is really hardcore ready for production. But I do think that, and the conversation started around this was because actually of my employer. So I currently work for Datadog, and we have a library that is used for profiling applications, taking distributed traces, and doing a lot more nice things. And a concern we always have is that we cannot impact the user application, and we don't want to have a performance impact on the user application. And so actually that blog post was a result of me discussing with my colleagues around should we start using Ractors? How can we use Ractors to make our code more performant and get more out of the way of the user's code? And that's kind of how I came into doing that blog post about Ractors.
Okay. So thanks, Valentino, for asking that much more eloquently. I wanted to kind of get into that as well as okay, so there's been a narrative about Ruby being slow for a long time. And I think those of us that have continued to use Ruby are either in my experience, one of two camps. One is you just accept it and you still use it because you're well, Ruby might be slow, but my development time is faster, right? Or I think there's also I think there's plenty of people, me included, right, who are well, typically the reason why you're quote unquote blaming Ruby for being slow is because you have some unoptimized portions of your code that you either haven't taken the time to fix or don't have the knowledge to fix, right? Or don't have a strategy for or something like that. And there's a lot of motivation in Ruby to just move forward with features and not go back and optimize. And so we end up in these cases. Do you feel like these new things, fibers, Ractors, whatever, maybe something that we haven't been talking about, do you feel like these things are going to help push us forward in that direction, performance-wise? Is that going to, and maybe even change the narrative?
That's an excellent question. So not quite. I actually don't think that Ractors will, they will change the conversation around that. People say, well, Ruby is slow because it cannot use all of the cores on your really fancy server or laptop. And so definitely Ruby will be able to make inroads on that. But because most people when they write Ruby code, they are thinking in a sequential way, their Ruby code will actually not get a lot faster by using Ractors. Ractors allow you to do more things at once, but the more things you are doing at once aren't particularly faster. So if you think of the kind of mythical man month, Ractors are about or even having a child. You can have more you can have more couples having children at the same time, but they will still take 9 months to get there. So that's kind of the metaphor to go from here, like from one couple to multiple couples.
That is a great analogy.
So, but they won't, like the individual couples will not get there any faster, and so I think to actually the get there faster portion is more on the work that has been happening around having either a JIT compiler in Ruby, such as mJIT that is already in Ruby, or YJIT that was recently added to Ruby and will be featured on the next Ruby release, 3.1, or even like the other Ruby implementations such as JRuby or even Truffle Ruby, which is showing really, really promising results. So you really be able to go faster in like a straight line. Ruby really needs a just-in-time compiler or something that optimizes code rather than just Ractors.
Okay. Anything that you feel like maybe we haven't addressed about this topic that you want to hit up?
Yeah, actually, about the Ruby performance, like another thing, going back to the whole discussion of like Ruby is slow, I think part of the problem sometimes is that you might not even realize that there is something that can be optimized. So you look at your code and the code seems straightforward. And so if you look at your code and the code seems straightforward and it is still slow, you think maybe it's just Ruby being slow, like my code seems straightforward. But I find that like Ruby is really powerful and really nice in terms of allowing you to, with very little code, do very powerful things and express what you're doing in a really easy way. But actually what is happening under the hood is actually something quite complex. So for instance, there's a common Ruby problem, a common performance problem